Something like 18 months ago, I made a video asking you all for some help trying to figure out what was the best media server CPU. Because your media server is only as good as the CPU powering it. So today I've got something actually really pretty exciting to share with you. I've built a new website to display and collate all of the benchmarks from the dozens of you that ran these benchmarks to determine which was the best QuickSync CPU. So I've put this website over at quicksync.ktz.me. It's a fully interactive kind of results dashboard, I suppose. And you can filter based on your username, based on the specific CPU generation that you're looking for. Really depends what you want to get out of this data. And please, I am not a developer by trade, at least, and I need your feedback to make this as good as it can be. And I need you to tell me the bits of information that it was a bit too hard to find this specific thing. So anyway, how to use this thing? Well, I'm gonna come on to how to submit your results in just a second. But first of all, load up the website quicksync.ktz.me. And let's say I want to look at 13th gen Intel CPUs. Maybe Newegg has a good deal on those CPUs this week or something. So if I just click on 13th gen here, you can see that it filters all of the 13th gen results into these graphs. Now, I've had it display 8th gen as like a baseline because I think that essentially looking at all the data, because of the hardware capabilities built into QuickSync for encoding, we don't really want to go much older than 8th gen. Technically, yes, 7th will work. And in fact, if you look on the About page back here, I've just copied this from Wikipedia and kind of made it a little prettier to look at. But here's all the different hardware codec support for Intel's QuickSync. Basically, this website is a one-stop shop for everything you could pretty much ever want to know about Intel QuickSync. So you can see that I've also got like a CPU scoring methodology here. So for right now, at least, and like I say, this is basically version 0.1. I need your feedback to make it better, hence why I'm making this video. You can see that the actual performance of the CPU only accounts for about 40% of the score, because there's no point in the CPU being the fastest thing in the known universe and consuming 1,000,000 watts of power whilst it does it. So efficiency matters, of course, but also the codec support. Like I say, you can't just have, a 7th gen CPU that only supports these older codecs and expect that to score as highly overall in the big picture of things as a more modern 11th or newer gen CPU. And of course, now AV1 is a thing. Arc GPUs factor into there as well with their ability to not only decode but encode AV1 as well. So there's also a leaderboard, so you can look at which CPU ostensibly is the best one, and the little algorithm seemed to come up with the fact that the 13600K is the best media server CPU right now. There really is no way to sort of say that there is one CPU that beats them all. I mean, if you look at my original blog post, which will be linked in the description down below, the conclusion really is that it kind of depends. It's so frustrating, but it depends on your budget. It depends on what's available on the new market, the used market at the time. It depends on the price of RAM, which has gone out the window right now. Maybe you can get a good deal on DDR4 RAM versus DDR5 from Facebook Marketplace round the corner or something. I don't know, but these are all the things that when you're building a media server kind of matter. We don't want to be chucking thousands of dollars at this thing. We just want to try and build something that's going to last a bit of time, but also grow and scale with our needs as we change as well. So the best media server CPU depends. It depends on you. Now let's have a little look through the rest of the website. There isn't much more to it other than sort of looking at the raw results. You can select more than one chip if you'd like. So if you want to see 9th versus 13th versus 8th, for example, you can see that all laid out clearly here. What I think is kind of interesting is you've got this CPU score here, which is just a raw software encode. And then you've got 4 different grades of QuickSync hardware encoding. And you can see pretty clearly that the 8th gen CPUs aren't actually that powerful. Like, look at the result here for the 8th gen of 42 frames per second output for CPU. The same file through QuickSync gets 166 frames per second. And then the difference between a 9th gen CPU and a 13th gen CPU is basically margin of error, 226 versus 233. And that's because the hardware circuitry inside for H.264 didn't really change much between those generations. However, if you start looking at some of the more intensive things like 4K HEVC 10-bit files, you see 29 FPS versus 20 FPS. That's a reasonable difference. It's still not huge, granted, but it's a reasonable difference compared across generations like this. Now, I need more data. I need more of you to submit your systems for testing. So how do we actually test this thing? Now, I'm going to load up my terminal here, make sure I'm on the correct tailnet so that my SSH works. I want to point out, by the way, that I had a lot of help writing the original script from a friend of mine in my Red Hat days called Captain Morgan, who's linked in the GitHub repository. And essentially, the process of running this script, it takes, I don't know, 5 to 7 minutes or so, depending on your CPU, of course. Now, this is the 13th gen i5 13600K. I promise I didn't bias the results on purpose to make my CPU the one that gets the highest score. It just so happened to be that way. And I would love to see, particularly as Intel's 14th and whatever they're calling their new generation stuff, the Core Ultra nonsense, couldn't we have just stuck with 14th, 15th, 16th? I understood that one. Anyway, marketing aside, actually running this thing is fairly simple. All you need on your system is JQ. In fact, let's go to the full instructions right here as part of the website. You need JQ. You need Intel GPU tools. You need an Intel CPU with QuickSync support, and of course Docker. So if you are on Proxmox, this is a Proxmox host. You just do apt install JQ and then Intel -GPU tools like so, and then it would install them for you. All right, so let's make a temporary directory inside of our home folder here, and then I'm going to do just the git clone. So this is going to clone the repo from GitHub, which you can find top of the page where it says GitHub. So if you want to audit any of the code and kind of figure out what the benchmark's actually doing behind the scenes, by all means, go ahead. Submit a pull request. I'd love to make this thing better. The one thing I would caution about this, though, is that we've already got a ton of results. So if you look at the original gist, which is where this is how people were submitting their results before, and then I was asking you to go through and make your own conclusions based on this. The one thing I would caution is if you are going to submit a PR, please try and respect the original data structures, because the submission APIs that I've written expect this kind of a format, and there is some validation going on there as well. So that's one small thing to think about. In terms of actually running the benchmark, like I say, it's fairly straightforward, and I am waffling on a bit tonight. I appreciate that. But let's go into our QuickSync calc directory that we've just cloned. So we did a git clone. We've cloned the repo. We now need to go into that repo. So we do cd QuickSync calc. And I'm afraid those of you that aren't particularly handy with the command line, I don't have a good way of doing this through a UI right now. Although it occurs to me, speaking out loud, it'd be pretty cool to run this as like an Unraid template with a web UI, and you click and it just does the thing, wouldn't it? Maybe that would be a good PR for you. All right, now it's just a very simple case of running this script right here. QuickSync benchmark. So what this is going to do is it's going to download a bit of my drone footage I edited together a couple of years ago just to use as part of this test, really, so that it's a standardized, like scientific experiments at school, standard experiments. You want to reduce the number of variables, right? So everybody's using the same 4 test files, and they have been since the data set was created, 2 years ago or whatever it was. These files, by the way, are very kindly hosted by Linode. So what's going to happen next is the benchmark script is going to pull down the Jellyfin container. It's the same one you would actually use if you were running a Jellyfin server. And then it's going to use the it's going to use the FFmpeg binary inside of the container to run these tests, again, to keep it fair. And also, I just didn't fancy maintaining an FFmpeg fork, and getting it to support hardware transcoding. It's more difficult than you might imagine. So What happens once the container's started up? As you can see, it will take 5 to 7 minutes. Don't worry, I'm not going to make you watch in real time. I will cut to when it's finished. It's going to run the 5 different tests. So right now it's running the CPU test. So if we jump into a separate SSH window and look at HTOP, you'll see that all of my CPU cores are currently pegged because it's doing an FFmpeg transcode in CPU, in software. Now the next thing that we're going to want to monitor is Intel GPU top. So you can see that I've now got a transcode happening in my QuickSync hardware engine as part of the test now. You see we've moved on to test number 2 back here. So it's doing the same file. Instead of it being 60 to 90 seconds, it's 15 to 20 seconds, just to give you an idea of the performance delta between even a modern Intel CPU, the 13th gen, and the QuickSync power. It's quite remarkable. I've got a couple of PRs on the repo, actually. There's one that I'm kind of sort of flirting with the idea of implementing here of concurrency. So this is a really cool idea, actually. So you can figure out where your limit is. And the idea being that how many concurrent transcodes can this CPU handle before it dips below real-time transcoding? So like 24 FPS or whatever your benchmark is. But whenever this speed number drops below 1x, that means your maximum concurrency was the previous result. So I'm working on adding this to the repo. There's a little bit of tweaking I've got to do with the results API now, I think. But this is a really cool idea as well. So we'll let this test run in the background, and I will cut to when it's done. I will just point out, whilst this benchmark is just finishing up step 5 of 5, how we get the power numbers for this script. And that's using Intel GPU top here. So these are self-reported power numbers. Now, I think in a perfect world, there would be a way to have you all run the exact same smart plug that can do calibrated power from the wall. Now, this is the real world, and we just don't have those kind. It's just not possible to really do that in a controlled fashion. Thus, we're going to have to rely on the numbers that Intel provide to us through Intel GPU top. That's why there's a requirement on that specific tool, by the way, because it's an important consideration. Like, you want to know how many frames per second you're getting per watt in. One of the things you'll find about the Arc GPUs, if you ever benchmark one of those, one of the Intel discrete GPUs, not the one built into the CPU like we're doing here, what you'll find with the Arc GPUs is they consume a boatload of power compared to the CPU tests, but they do it in a fraction of the time. And so there's always that thing of like running in the rain. Do I get wetter if I run in the rain and do a transcode fast and use a ton of power doing it? Which is more power efficient? Hopefully this gives you the data to figure that out. All right, so the results are now complete, and you can see here this is the old format here that you would have pasted into the gist. However, now I have a fancy new submission API. All right, so let's click on the results page. I'll do a command click in Ghosty. And you can see I've got some fanciness. I have a little Cloudflare capture. Very proud of that one. We import your data into the system, and then I can put here, I can put Ironic Badger, and this step is completely optional, but I'd like to know which results were mine, and then just submit the results. And that's that. You've just submitted your results to an open database for the benefit of your fellow Home Lab enthusiast. And you can see I can now just select all of my results here and look through over the years, submitted on 12/5, American dates. I will never get used to it. I've lived here for 7 years and I'll never get used to it. 12/5/2025. I guess that must be set to UTC because it's currently only the 4th of December, not the 5th, but there you go. Such is life. There's the test we just did with all the results. So please go ahead, follow these 3 commands, submit your results. I really want to just try and get this total unique CPUs as high as it can be, and the number of results sky high. It would just be amazing. Like, there is nothing else out there quite like this that's testing one specific aspect of building a media server. That is, the CPU selection is one of the more important things. Like, should I select a CPU with a T after it? No, don't do it. It's a common misconception that the T branded CPUs are better because they've got lower TDP. Well, they don't idle at a lower power consumption. They just cap themselves in terms of utmost performance. Maybe in some small form factor applications like the 1 litre PCs, you'll quite often see those T variant CPUs in there. They are thermally constrained, like properly, because they're such a small chassis, whereas you are most likely, at least, building a server with, I don't know, half a dozen hard drives in it, and you've got room for a desktop-sized cooler. So you don't need to limit, probably at least, you don't need to limit yourself based on thinking lower TDP also translates into lower 24/7 energy cost. It doesn't. So by all means, take a look and let's find a T variant CPU in here, for example, and compare it. So i7-8700T, for example, you can see here how that compares. I was going to say how it compares to an 8th gen. Well, it is an 8th gen. How it compares to a 7th gen, for example, and get an idea of what those tiny mini microsystems can do and how they kind of output their QuickSync data. So that is honestly this website. I can't tell you. Like I built it in a couple of nights using Claude Code. It's an AI generated piece of vibe slop, but I don't know. I think it's pretty cool. I hope you find some utility from it as well. And please, if you are an expert in such things and want to fix something, PRs are well and truly open for business. I do want to add NVIDIA support at some point. I'm kind of thinking about how I can do that and integrate the NVIDIA stuff and even the AMD. AMD have added hardware encoding for video now as well. It'd be pretty cool to add that in here and find a way to not mess with the original data structures. Yeah, that's probably a future project for me and Claude at some point. But there you go. That's a little update what I've been up to. I'll probably do an actual proper channel update at some point soon, because by now we should have moved back to England. For those of you that don't know, we finished the self-hosted podcast in May, and I proudly announced we're about to sell our house and move back to England. And yet I'm still here. I'm still in America. Nobody's buying houses right now, it turns out. The economic forecasts and what have you and all that, I don't know. We sold everything we owned. In fact, in June or May or June, we had a wonderful day where about 30 or 40 of you came to my house and bought all of my servers, and I've sold all my woodworking gear and everything else. Like literally all we've got left in the house is what you can see behind me. We've been living in a show home for the last, I don't know, 3, 4, 5 months, whatever it is. Kind of sucks, but at least we have a roof over our heads. Oh, the other thing I wanted to talk about, and this isn't related to QuickSync whatsoever, but it is related to podcasts. And I'm going to assume that if you are still watching, you're the kind of person I want to hang out with. So, in the new year, do I want to say this? Okay, I think so. In the new year, I want to reboot a podcast. It might not be called self-hosted. In fact, it almost certainly won't be called self-hosted. I think that body of work is probably best left alone as a standalone piece of work, piece of history, But I want to talk about Home Lab. I want to talk about the news of the wider tech world. Self-hosted in and of itself kind of limited itself to a certain crowd, which was fine in some ways, but I always felt a little hemmed in by the topics we could cover. And so I'd like to investigate working with one of you or two of you, a 2 or 3 person podcast would be fantastic. Early and launch it early in the new year to talk about Home Lab, to talk about the wider tech world, to talk about self-hosting, of course, because that's core to my being and has been for as long as I've been into computers. Networking, of course, I've got some overlap with the stuff I do at Tailscale on a daily basis. Farting about with this stuff, media servers, and just, nerding out about cool open source projects and Linux and the world at large, perhaps. The vibe's going to be fairly similar to self-hosted, like a bit of a show, but also a bit like going down the pub with your mates and having a chat. So if that's of interest, DM me on Discord. I'm AlexKTZ. You can still find the old self-hosted Discord at selfhosted.show/Discord, I think. Come find me, ping me at AlexKTZ, or is it Ironic Badger? I don't even know. You can also find all of the places where I exist on the internet on my brand new little mini Linktree website that I vibe coded. I've just been having a great time with Claude. this month. And yeah, you can find all the various places I am online, of course, at alex.ktz.me. So there you go. I hope you get some utility out of today's video and enjoyed the last little couple of minutes of insight into what I've been up to, because it's been somehow nearly 6.5 months since I made an upload. Oh, that's painful. Anyway, until next time, thank you very much for watching. And I've been Alex from KTZ Systems. Goodbye.